everyone. My name is Amit. Today we'll talk about mastering microservices at mega scale, and we'll do a kind of a DoorDash case study here. To get started, let me introduce myself. I'm Amit. I'm natively from Pune, but been in Silicon Valley, Sunnyvale, for about 18 years now. And with that, let's jump right in. So I don't know how many of you might be familiar with what DoorDash is. So let's talk about what DoorDash is anyway, and then we'll jump into the mega scale of it. So DoorDash is a market leader in food and grocery delivery in United States, and it operates in Canada, in Europe, Japan, and other countries as well. So if you look at the numbers, this is Q4 2023 numbers. So the market cap, or the way it calls it is marketplace GOA, is around $17.6 billion. That translates to about 574 million orders. These are food and grocery deliveries that were done in one quarter alone. So that's like a lot of food and groceries being ordered. And if we do a deep dive into the orders to make it a little more interesting, so if you break this down into orders per day, so diurnal traffic, around peak traffic is around 590 orders per second, which translates to about 35k RPCs per second. And this is just the order traffic, where percentage of daily active users actually placing an order. But the actual number of amount of traffic on the stack is much more, because daily active users are browsing through the restaurants and menus and writing reviews or reading reviews and so on. So that's over 500,000 RPCs per second. And there is another multiplier there that we are not talking about. This is just the RPCs. There are async flows going on, and including Kafkas or Airflows or Cadence. So that is on top of this database as well. So what's under the hood that's driving this scale is spaghetti of microservices and databases interconnected to make that happen. So this is a graph of more than 1,000 nodes, where every node is either a microservice or a database connection or a Kafka queue. And this is collected through OpenTelemetry tracing. A quick look at the stack itself. So DoorDash is primarily Kotlin house on the backend. Node and Python is used as well, but the Kotlin is the primary language, which is a kind of a variant of Java, and it's tens of millions of lines of code overall. Hundreds of developers working on hundreds of megas repos or poly repos. So DoorDash is kind of a lean organization as far as the scale is concerned, and we see around thousands of GitHub merges per day. On the tech side, so it's kind of usual suspects there: Kafka, Elasticsearch, Envoy, Redis, and a bunch of database solutions. So let's look at how DoorDash kind of evolved into microservice architecture it is today, and how it tackled the scale while being on that journey. So part one is breaking down the monolith. DoorDash started just like a lot of other startups, where started out with the monolith, let the concept evolve and prove itself, and soon enough we wanted to break down the monolith into microservices for a lot of different reasons. And this was a huge effort, multi-year, multi-team effort, and mainly we used strangler-fig pattern with a lot of scream tests, and eventually we had to ordain a mandate to get rid of the monolith, and that resulted in thousands of microservices. So this is where the journey began, and quickly you come to kind of realize that how do you talk to each other? When you have these many services, you need to solve the service discovery problem, And the way DoorDash solved it is using standardized DNS scheme, which is internal to DoorDash. Also using client-side load balancing, where clients do the DNS resolve, have a small cache of IPs, and rotate through that randomly. So kind of rely on system entropy for randomness there. And then comes the scaling challenges. Now we have thousands of microservices and developers happily, submitting changes to it. But soon we realize that if your call stack, for example, has 10, if your subgraph of the stack has 10 services that you rely on, and you want to test one of those, how do you really do that? It's not as straightforward as you would think. For Monolith, you can create an environment to bring everything up on your laptop, for example, or dev environment, and go with that. But for microservices, teams could be owning few, and there might be other teams who are responsible for others that you're dependent on. So testing is an interesting problem in microservices in and of itself. Manual deployment. So manually testing the changes and then going through the phases of canary or gradually rolling it out. So that is another scale issue that needed to be looked at. Also, when the rollout is happening of a new release, it goes through various, for example, geos, or we have cells, for example, and you need to be able to make sure that it is successful in one geo before you promote it further. Other important aspect is load testing. Let's say at such a scale, you want to accurately make sure that you're going to be able to hit the peak traffic coming next holiday season. How do you accurately do that without impacting the ongoing money-making traffic? So in order to do that, that brings us to part 2, that is solving for scale. And DoorDash is one of the pioneers in using the same stack for both test and production traffic. So it's testing in production. And there are multiple benefits of doing that. Is that first is high fidelity in testing. So for example, you want to test service A, what you do is you kind of hot swap the node in the graph with your kind of a sandbox or dev environment, and magically the traffic flows through your environment while the rest of the stack remains the same. And this is quite powerful because it allows you to have same stack but being able to use it at will for testing. So here we are hot swapping single node, but you can very easily do it for multiple nodes as well. So if you're working on a feature, for example, that sprawls across multiple services, you'd be able to use the same underlying tech to test in prod. So this is a multi-tenant environment where every piece of the stack understands tenancy, and we'll talk a little bit more about that. Load testing is accurate because let's say you want to test your stack, whether it's going to meet the peak or not. So you are actually pushing test traffic through the production stack. So it can be as close to the reality as possible. And testing in prod makes that possible. So one thing I'd like to enforce is that what testing prod is not. We are not pushing features to production and exposing users to it. That's not what it is. It's actually like we saw earlier, we are hot swapping nodes of the call graph with test and dev environment, and you're reusing the rest of the call stack. So for this, we need multi-tenant environment. So DoorDash was at crossroads between coming from Monolith to new microservices world. It had staging environment and it had different dev environments, but those did not scale for various different reasons, lack of SLOs and operational overhead. So that's where the decision quickly we realized that we needed something like testing in prod to be actually able to scale it to the level that we want, as well as reap the benefits of that architecture in the production environment as well. And to enable that, so stack needed to be made multi-tenant. And when you want to do that, quickly you realize that you want to know at every level of the stack what is the tenancy that you're dealing with. So for whether it's a database query or a Kafka event or an RPC. So we leverage open telemetry for that. There were a couple of talks here about that as well, and it's a distributed tracing infrastructure which does context propagation, and we tack in a tenancy context to it that gets automatically propagated through RPCs, through Kafka, through other async flows. For routing to different nodes of the call graph, depending on what you want to test, we leverage service mesh for that. So Envoy routers understand the notion of tenancy, and they are able to route at will to different dev environments, including your own laptop, for example. And other aspect of multi-tenancy is that we want to make sure that the business logic is as agnostic to tenancy as possible. It doesn't need to know what tenancy is dealing with. We want to offload that logic to the platform layer. For example, if for example Redis, we would want to build a Redis shim on top of the library that you want to use, for example, and that Redis shim understands the tenancy, and it is configured in a way that if it's test traffic, go talk to this cluster. If it's prod, go talk to the other cluster. And so when we talk about multi-tenancy, this applies to not only test traffic, but it also applies to different lines of businesses. For example, DoorDash has different lines of businesses like Drive or Caviar. So tenancy, this tenancy platform can easily be leveraged by that as well. Testing the limits of scale. So once we have the multi-tenant environment, we are kind of creating a different realm using the same stack, and in that realm we can create new actors, whatever that you want to test with. And typically what we do is, let's say Friday afternoon is the peak traffic that you get. We actually load test on Friday afternoons and push more test traffic on top of the current production traffic that's there. So that allows us to make sure that the stack is able to withhold under pressure. Next comes, so there are two parts we spoke about. One part is how the journey started with from Monolith to microservices, and second is about building this multi-tenant environment. So once you have those in place, there are some other aspects that you need to solve for. One is the standardization of the platform itself. We saw about the Redis library, for example, which is able to understand tenancy. There are other aspects in the system, for example, circuit breaking, where when the circuit fails open, you don't want that to be failed open for production traffic when the test traffic is creating the noise and the issues. So circuit breaker library needs to be taught or made tenancy aware, for example. So we want to standardize and the logic and the common patterns in the platform libraries, and this not only helps with multi-tenant environment, but it also helps with pushing changes faster at the platform layer. Other aspect that we spent a lot of time in was deployment. So typically this was done manually, where new releases were tested in some special environment and then pushed to production and then watched for whether anything goes wrong with it. So here what we wanted to change is that once a developer creates a pull request and it's ready to merge, it should be put on a conveyor belt and let it roll to production at automatically with proper automated validations, testing, and guardrails in place. So that's what we call zero touch deployment, where service owners set a schedule for their deployment of their service, or they would, if they want it to be merged or promoted as soon as the code is merged, that's fine as well. But as soon as the code is merged, it's handed off automatically and pushed to production at the defined schedule. Along with this, there's something very interesting and very crucial to bring in developer velocity is make sure that if something goes wrong in production, we would want to pull back and roll it back as soon as possible in an automated manner. So a lot of times when there is an incident, we jump on the call, try and figure out what happens. Then someone realizes, oh, let's roll back, and there is some thought, decision making that needs to happen, whether we should roll forward or roll back the changes. But it oftentimes, being more aggressive about rollback is seldom a bad idea. It's okay to roll back quickly with hopes to mitigate outage. Of course, we don't want to cascade, do a kind of runaway rollbacks for a lot of different things, but being aggressive here could help. So this is one of the things we are automating, where automated systems monitor the SLO burns or metric deviations and automatically roll back any newly done changes to the system, whether it's config changes or release changes. So to sum it up, let's go through the takeaways, or how I can do it, how I can get to scale my microservice stack. So first and foremost is limiting the sprawl of X stack matrix. For example, teams shouldn't have the free will of the what library they want to use or what cache tech that they want to use. That puts in a lot of operational pressure on the platform layers. So limiting that and having some opinionated decisions made, that helps overall. Smarter platform with abstraction to common patterns. So this is where the platform libraries come in, where we have libraries for common systems that is getting used. For example, databases or caching, or even Kafka, for example. And having those shims allows a lot of flexibility and control over what we want to do at those layers. And this frees up developers from having to duplicate code and having that scope of user error or bugs creeping in, because the developers are having to do some of the platform work in their business logic as well. So abstracting that out in the platform, that brings a lot of velocity. Last 2 points are about zero overhead testing, which we just saw was about making sure the deployments are automated, and even the rollbacks, and quickly mitigating incidents or issues is crucial for faster development. Yeah, with that, that's all I have.